Hello everyone, today in this video we are going to derive the expression for error propagation in power of a physical quantity. So after this video you should be able to derive the expression and solve the numerical on error propagation. So error in nth power of a physical quantity. Measure value of A is A plus minus delta A. Delta A is the mean absolute error. Suppose C is a physical quantity which is equal to nth power of A, and the error in C is given by C plus minus delta C is equal to, I put the value of E plus minus delta E to the power n, and I'll take E common outside, so it will be 1 plus minus delta A by A to the power n. Now I'll divide both sides by E to the power n. So this E to the power n, A to the power n get cancelled. Now I'll separate this A to the power n out here, and A to the power n is C, so I can put the value out here also. E to the power n is C, so C get cancelled. And if you see this term, delta A by A is very small as compared to 1, because the error is always smaller than the true value, so this term is very small. And if you use binomial theorem, then 1 plus minus x to the power n, when n x is less than 1, we'll get 1 plus minus nx. So I can write 1 plus minus delta C by C is equal to 1 plus minus n delta A by 1 get cancelled, and I can cancel this plus minus also. So I'm left with delta C by C is equal to n times delta A by A. So the maximum fractional error in nth power of a physical quantity is equal to n times the error in the individual quantity. So just we have to multiply the power with the fractional error of the physical quantity. So now let's see all the formulas. In addition, the absolute error in the addition of two physical quantity is sum of absolute error of two physical quantity. In subtraction also we have to add the errors. In multiplication we have to add the relative error or fractional error of two physical quantity. In division also we have to add the fractional error of two physical quantity, and in nth power we have to multiply the fractional error of the physical quantity with the value of the power. So we'll be using these formulas. So now let's derive the general formula. Suppose I have P is equal to A to the power W into B to the power X divided by C to the power Y and D to the power Z. Now I have to find the percentage error of this. So first I can see is multiplication of A and B. So in multiplication we already know power get added. So out here you can see delta C by C is delta A by A plus delta B by B. So I can write delta A by A plus delta B by B. Next we have division by C and D. So we know in division also we add the fractional error. So we need to add the fractional error of C and D. So I just add the fractional error of C and D. So multiplication and division is done. Now I am left with power. So in nth power we have to multiply the fractional error by power. So we just need to multiply this delta A by A, delta B by B, delta C by C, and delta D by D with the power. So I just multiply with W, X, Y, and Z. So this is the relative error. Now I have to find the percentage error, and we know percentage error is relative error into 100%. So this relative error into 100%. So I'll just multiply everything with 100 and write percent. So now I'll multiply this 100% inside the bracket. So next is now delta A by A into 100% is the percentage error of A. So the final formula is percentage error in P is equal to percentage W into percentage error of A, X into percentage error of B, Y into percentage error of C, and Z into percentage error of D. So in order to get the percentage error, we'll add the percentage errors by multiplying them with the value of the power. So let's see one question. The side of a rectangle are 10.5 plus minus 2 and 5.2 plus minus 0.1 centimeter. Calculate its perimeter with error limit. So two things are given. L plus minus delta L is this, B plus minus delta B is this. So we know perimeter is 2 length plus breadth. So I have to add the error also 2 times. So out here you can see L and B is 10.5 and 5.2 and errors are 0.2 and 0.1. So this is the perimeter 3.14 plus minus 0.6 centimeter. So in addition, we have to take care of this constant also. So now the radius and the height of a solid cylinder is measured as 10 plus minus 0.2 centimeter and height is equal to 20 plus minus 0.5 centimeter. Calculate the percentage error in volume. So two things are given. R plus minus delta R is this, H plus minus delta H is. So volume is pi R square H. Let's find the relative error in V. So delta V by V is equal to, you can see there is multiplication of R and H. So I can write delta R by R plus delta H by H. So the power with R is 2. So I'll multiply this with 2. So I'll just ignore the constant because constant do not have any error. So now put the values. So delta V by V is 0.065. So percentage error is now multiply this with 100. So 6.5 is the percentage error in finding the volume. The next question, a physical quantity P is given as P a to the power cube B square divided by root over C into T. So percentage error in A is 1, B is 3, C is 4 and D is 2%. So I have to find the percentage error in P. So first I'll write this in proper way. Now again I can see there is multiplication and division. So root over means power half. So now delta P by P is 3 into delta A by A, 2 into delta B by B, half into delta C by C, half into delta D by D. So percentage error is, now I'll just multiply both sides with 100. So now this term is percentage error in E, and this term is percentage error in B, and this term is percentage error in C and percentage error in D. So I'll put the value. So 3 into percentage error of A is 1, percentage error of B is 3 into 2, and half into percentage error of C is 4, and half into percentage error of D is 2%. So now 12% is the error in P. So you can try this question.